can replace the conventional biogas, concrete and plastic-based biogas, which is being currently used around. So this biogas digester could handle any type of organic waste, and the USP of this lies in the very cost-effective and the material, and also the quick installation and of this particular product. And there has been a lot of R&D work which has gone into this product for the last few years, collaboration with universities and demonstrations, etc. So now we are launching this product with the Indian market with various organic waste, with special focus on sugar industry. If you this is how the digester looks. This is a 100 cubic meter digester which was installed recently in Indonesia. So as you can see, the product, it's quite different from the digesters which you would have seen in the market today. It's totally a different product where no concrete, minimum concrete work is put into this particular product. The waste here in Indonesia is a palm oil industry waste. It's a 100 cubic meter digester which is currently already in operation. The digester size, when you if you have any questions, you can always stop me and ask me then and there. When it comes to this digester, the scale ranges from 1 cubic meter to 100 cubic meter, and of course this can be expanded into different modules, 4 to 5 modules of 100 cubic meter, even larger size. So one you see is one of the smaller digester which is being installed. When it comes to waste, what type of waste would this be able to handle? It could basically handle any industrial or organic waste, like agricultural waste. Let's say if there are cattle farms, dairy industry, or else we can say fruit markets, like vegetable markets. When it comes to more specific about the process industries, industries like sugar have a lot of waste generated, like spent wash and also press mud, which is being currently used for partially for biogas and partially for biocomposting and so on. But specifically, press mud would be of something of interest to us, because we are already started to work with a couple of clients in India, sugar mills, for installing press mud based biogas digesters. Other than this, if you have a canteen or canteen waste could be used here, like in government organizations, like let's say municipalities, waste, so on. Those kind of waste could also be used here. So this is just a picture of different waste, and you can see the press mud picture in the left bottom corner. That's the press mud, a special feedstock which is generated from the sugar manufacturing process. I will present more about press mud as we proceed in the presentation. If you look at the difference between this digester, when you see when after the manufacturing, the one in the gray, the right side, you can see how easy it is to for example, to transport. It's already industrially prefabricated, and it comes in different sizes, and it can be customized depending upon the requirements of the customer. And its most important thing is it's always cost effective compared to the most of the conventional digesters which are available in the market today. So if you look at this factory tested. So before shipping it to the customer, the digester is completely tested in the factory for all kind of wears and tears and industrial test, and to meet all the requirements. And as you can see there, it's a production line already which is existing, and it's a special kind of building which is deployed here to make this particular fabric. And this might be an interesting picture. You can see how the digester, like the material, could be folded even before, before shipping or transporting to the installation location. So this is one of the main unique advantages of this particular digester. It's very easy to move around, easy to transport, and which also makes the installation time much faster. It's foldable. The storage, the biogas can be stored. The digester can be also be used as a storage, like the storage point as well, storage bulb. But always an external storage point can be always installed as well. So that's the groundworks. You can see it's a basic groundwork which is required for setting up this digester. As I said before, this was in Indonesia, where the digester is currently under demonstration. So it has been various sizes have been tested. So it's a very lightweight fabric, flexible, and most importantly, it's resistant to high temperatures, very high resistant to UV light and other kind of external factors. If you look at this, this is how a conventional digester, I'm talking about a small scale digester. It could be made of concrete. You can see you need to put in a lot of concrete work here, or you have to put in a lot of steel based digesters, which is not so environmental friendly, also not so cost effective compared to this particular digester, where you can see it's more like environmental friendly and very quick to installation. So it has many other advantages compared to a conventional based digester system. Now I'll talk more about specifically about the sugar industry, why this is very interesting for the sugar industry and what are the applications where this digester could be applied in the sugar industry context. People in sugar industry and also others as well know that sugarcane is it's one of the plant in the world which is the most diversified plant. You have no other plant in the world which would give you so many byproducts from a single plant. That's why sugarcane is a very interesting plant. Of course, the main product would be the sugar. That's the main product where you get from the sugarcane. Other than sugar, you get bagasse. The bagasse, which is used for power generation. After the crushing of the cane, you get something called bagasse. It's similar to biomass, and you have you can make alcohol, ethanol from the molasses. So there are close to 40 byproducts like chemicals and different kind of industrial products, which could be industrial alcohol, etc., which could be made out of the sugarcane. But there is one, if you look at the one in the middle, press mud. This is something, it's a byproduct. It's also a byproduct which is generated during sugar manufacturing process. Today what sugar mills do with this product is they don't use it like in a, let's say they use it only, they sell it as a low-cost manure to the farmers, or they mix it with spent wash. That's another waste for biocomposting and selling it as fertilizer. But there is no, let's say, large-scale value or a big economic value today which is being generated out of this press mud. What we have done is we have done a lot of R&D work for the last three and a half years to 4 years to estimate the potential, because biogas can be generated from press mud. Press mud is one of the very good feedstock for biogas generation. The biogas generated through press mud can be used for let's say power and heat generation. The power can be generated via a biogas engine, biogas CHP as they call it, so you can generate power, and you also can recover waste heat through the waste heat recovery boiler, or else you can upgrade the biogas to bio-CNG. Bio-CNG is nothing but it's a replacement for natural gas. When you have a methane of 95% or more, then it's the gas, the quality of the gas is similar to natural gas. So this could be used as a replacement for natural gas. Where India, we have a huge natural gas deficit, so that's one of the interesting applications. Or else the gas generated from press mud can be used for steam generation. For example, it could be used in the sugar mill operations where you require a lot of steam in various processes. It could be used in distillery operations because you need a lot of steam again in distilleries. Or the other alternatives, it can be used as a replacement for LPG-based cooking, like in houses like sugar mill quarters, or it could be used in canteens. Because one of the interesting applications where we plan to install a biogas digester for a sugar mill here in India, where they'll be using the gas for the canteen because replacement for LPG. So there are a number of areas of application where the gas generated from press mud can be used. Of course, other than press mud, there are other waste generated in the sugar industry like spent wash. This could be also used as a feedstock for generation of biogas. I'm just giving you a few examples like where it could be used, like pipe cooking line for housing units or for sugar mill canteens. And also that sugar mills in north of India, they operate only for like 120 days to 150 days. During rest of the year, they can generate power by storing the press mud and generating power using biogas engines. So during off seasons, when there is maintenance and overhauling work going on in the industry, you could use it for the internal consumption of the sugar mill, because at this time you might not have bagasse, because all the bagasse-based plants will be shut down, sugar mill will be shut down during this time. So it's during off season you could make additional revenues by generating power using this particular feedstock. So in the sugar industry context, this particular digester from specific digester could be very interesting, because as you see, it's quite easy to install and operate. I will share a case from a customer case in India, a sugar mill in India, where we will soon make an installation. The current LPG consumption of this sugar mill canteen is about 55 to 19 kg. That's an industrial cylinder, like we call it commercial cylinder. And the value of each cylinder is around 2,000 to 2,500. So the yearly consumption of the sugar mill is around 600 to 650 cylinders. And what we have proposed to the sugar mill is to use just 1 ton of press mud. That would be a 100 cubic meter biogas digester. What this 1 ton of press mud would do in a day is, or I would say in a month, is it would replace close to 50 to 55 LPG cylinders. In a year, that would be around 618 cylinders. Roughly, the sugar mill will be able to save around 12 lakhs 30,000 rupees annually by replacing the LPG by using our digester, this particular digester, which is much more, which is going to give the sugar mill a very faster payback, and you can completely replace the LPG consumption. And this is just one of the examples. I mean, when I talk about LPG, but as I said before, you can replace or you can generate power using this gas, or also you could generate bio-CNG and steam, etc. If there are sugar mills, because in India there are many sugar mills who have large canteens. They have a large housing units, like 200 to 300 people staying. So a pipeline connection can be established for such sugar mills as well. Or you could set up a separate standalone biogas plant for power generation and so on. This is just a process overview how the installation would look like. You have the pre-treatment tank or pre-mixing tank, where you mix the press mud with almost 1:1 proportion or 1:5 proportion of water. Then you feed it into the digester. That's the special fabric-based digester. And if required, there is normally no required for H2S scrubbing. It depends upon the end application where you need the H2S with gas to be used. The H2S here is very low. It's very low. It's like 300 ppm, which is much lesser than compared to spent wash-based biogas, which runs into 30,000 ppm. So this is another advantage of press. It's a lower ppm allows the digester, and it could be used for many other applications. Once you take the gas from the digester, then you can store it in a separate gas storage. For example, in this case, I have the case of a sugar mill kitchen. So you could store it close to the kitchen and then use it on demand, like it's like a gas flow line. You need to switch on the gas burner. And yeah, just you can have a flow meter to measure the consumption and other parameters as well. So this is how a typical installation would look like. It's pretty much similar to the last slide, but you can see the reactor here, where you have the inlet after the mixing tank, and it could be partially under the ground, and you have the outlet as well. The movement inside the digester, the movement of the organic waste is more on a gravity-based movement, because it will be kept at an inclined position where the digester just keeps on moving, that the digestate keeps on moving. So you can feed in 1 ton or 1.5 tons every day, and corresponding amount just flows out through the storage tank. And also another important thing is this. the digestate or the waste which is coming out of this digester can be used as a very high quality organic solid fertilizer, and you also get a liquid fertilizer as well. I mean, on commercial basis, one could also sell this and bottle it and sell it to farmers at a, just to test it as well. So we also plan to do this as well, like test the waste and bottle it to give it to the sugarcane farmers, for example. Also the most important thing is we always have a ground support is wherever we install. For example, in India we have a partner like us to support the installation. In other countries like in Indonesia, you can see that there are partners in Indonesia as well. So we give the support based on the business case. We install, and we also in some cases operate the plant for a few months, like 3-4 months or more, to stabilize the plant, and we also do offer some maintenance as well. Also, the most important part is to educate the, let's say, the users of this biogas plant. It could be the sugar mill, or it could be educational institution, or it could be a like a marketplace, because I think the operation of biogas plant depends largely upon the operator, since it's a biological process.
You can use that play sound over there. You can.
Hello.
Right, sir.
Hello.
Hello. Yes, Mr. Joseph.
Okay, yeah. So you could, I mean, I think education is the one of the most important part of biogas plants from our experience, because the people who are operating should have a good knowledge about how to feed in and proportion of feeding rates and so on. So we also provide that support initially to educate the operator of the plant to make it operate continuously without any interruption. So you can see that these are some examples, pictures from Indonesia, where we have the local support and local people helping us for installation and maintenance work. Because when we talk about biogas, I mean, generating methane is quite easy, but we have to use the right parameters, because there are a lot of metrics like organic waste, total volatile organic percentage, pH values, and so on, many the ratios, CN ratios, and the proportion of moisture with the dry part. These metrics have to be taken into consideration before installing the plant. With a good knowledge about various feedstocks, including pressmud, for example, you'll be able to support the customers. If you look at the model, how this could be implemented, we offer the customer upfront sales, the digester, we sell it upfront directly, and also we all have an option where we could have a demonstration where we set up the plant for, let's say, between 3 to 6 months. We demonstrate the plant and show the customer how to operate it, educate them, so on. Based on this, they can continue on buy the system from there as well. So we are kind of flexible with how to operate this digester, and also as I said before, one of the advantage of this particular product is that it's quite module based, that you can always add. Like if you have like 10 tons, then you can make 200 cubic meter size digester into 5, so you could always add on the number of modules. As you can see, it's minimum concrete work or other steel works. So it's the fabric, the digester in itself, which has to be installed, and the piping connections have to be made in place. So you can always scale it up to the level you want based on your requirements. That's like you can see one of the smallest one in the right side, and you can see the one of the largest digesters. So you can choose if it's for a small household, for like 10 house or even 1 house, you can have this organic waste in your house and just connect it to a gas burner, biogas burner, and generate biogas. Or else you could go for a larger scale, for example, like a sugar mill or a paper mill or tannery mill or leather industry, etc., where you have a lot of industrial waste coming out, where you could install a large scale digester for consumption inside, for captive consumption, like inside the industry. So you don't buy, let's say, power or steam from external, like from the grid or from the from the government, for example. An installation normally takes an average of 1 day. Of course, this depends upon the piping work and everything. You can see that there is a very little material needed for installation. You can see some PVC pipes and some connectors, etc., which need to be installed. It also depends upon the case-to-case basis. After analyzing the customer case, we would suggest the right installation time and materials which are required for installation. So this is one of the demonstration I showed before. This was an 100 cubic meter biogas reactor. So the plan is to operate it for a few months and evaluate the complete operating procedure, etc. So this is one of the unique business models where we give an option of demonstration, like a demonstration first before the customer, based on the performance, etc. It gives the customer confidence. We have an agreement with the customer where they have to buy after a certain time, or they can always buy upfront as well. That's for a small household reactor. You can see, I think this ones are in orange. I think the ones produced from now will be more in gray color. It's more like industrial color. So you can see one of the smaller installations, even 10 people house or 2 people house, whatever it can be used for such applications as well. When it comes to the startup procedure, it's pretty much similar to conventional biogas plant. You could use either manure inoculum, or you could also for sugar industry. You could also use spent wash waste. If you already have a spent wash biogas digester, you could take the digest from there, and you could also start the process used here. And when it comes to the number of retention days, it's normally around 30 to 40 days for pressmud-based biogas plants. So after this, you would have a stabilized gas production continuously. The lifetime of the system as a whole is more than 10 years. I would say 15 years, but just to be on safer side, let's say more than 10 years. Payback time is less than 3 to 5 years. This of course depends upon the case to case and also what kind of application it's being used for. For example, LPG replacement is a very good option because LPG being a very expensive commodity in India, it would be a very good replacement for LPG waste as well. And there is also the possibility of carbon offsetting programs. Of course, this depends on the country to country as well. And also you could have this organic fertilizer. It's an additional value-added byproduct. So the cost is it's a system that is quite cost effective. That's one of the major advantages other than the digester itself. You could, as I said previously, it's a faster payback, and you could always make your investments gradually scale up the investments. So this the product is in itself is a very successful and tested product. It has been tested in different countries, as you can see, in collaboration with different universities. For example, like in Sweden, it's the University of Boras has the collaboration. FOV has a partnership there. In Brazil, there have been some demonstration installations which have been done there as well. In Nigeria, Vietnam. Now the largest one, the 100 cubic meter, being in Indonesia. So it all started from a lab scale where it was tested initially, then it was slowly scaled up to the industrial level. So basically we have a global R&D support, and we also intend to cooperate with some of the leading universities in India to further develop the product and also to localize it to Indian conditions as well. So this is one of the other prototypes of the biogas digester. So that's few universities in the world. The FOB management makes trips and makes collaborations with universities to develop the product, to understand the local needs, because it depends upon the requirement of the local industry in the local country. yeah, so making all the work trips and gaining a lot of experience. So here we are here today to launch it in a commercial level. Hopefully, sugar mills will find this of interest. As I said, the difference before, the unique differences are listed. It's durable, easy, shorter paybacks, university tie-up, and so on. So this is about FOV Fabrics AB, because FOV Biogas AB is a spin-off from FOV Fabrics AB. FOV Fabrics AB in itself, the parent company, has a long history of having a very well-known customers like Louis Vuitton, Puma, Formula One. You can see the airbags for inside the cars. So they have the experience of supplying to many global customers. You can see many automobile companies like Volvo, BMW, Scania, and many other customers. So this in itself proves the reliability of the product and the technology as well. And many other manufacturing processes use this similar material which is supplied by FOB Fabrics AB. So if you have any questions, you can always email me, joseph@notcleantech.com, or you could contact Frederick, the business developer and the representative from FOB Biogas, or you could also visit the website www.fobbiogas, and you have my local contact number in India here. If you're a local sugar mill, you could always call us up, and we'll be glad to discuss and offer you the suitable solutions.
Okay, thank you, Mr. Joseph.
Thank you. Yeah.
Yes, thank you, Mr. Joseph, for your presentation. I would request the participants to type the questions in the chat window in the right side of your panel. Mr. Joseph, we have few questions from Mr. Tiruvallur Kesavan. The first question is, what is a typical cost per cubic meter?
Typical cost, this would more depend upon the let's say the feedstock, what type of feedstock you are and what is the end user application. Is he specific about any particular feedstock?
He's from sugar industry, sir. Mr. Kesavan is from sugar industry.
Okay, let's say 100 cubic meter would be in the range of around, this is like the introduction price, the demonstration price would be around 14 to 15 lakhs, 100 cubic meter digester.
Okay, thank you, sir. The next question here is, can we use 100% spent wash, and if so, what are the reference plants and the capacities?
You could always use 100% spent wash, but also the important thing is what would be the gas generated from spent wash be used for? What would be the end application? Because if it's for power generation, spent wash has close to 25,000 ppm of H2S. So this has to be scrubbed. For example, press mud has only 300 ppm. Here we don't need even scrubbing. It could be directly used. They could use spent wash without a scrubber if they're going to use for steam generation. If they want to boil it inside the boiler, let's say a biogas furnace for steam generation, then it could be done directly. But if it's an engine, then 25,000 ppm is too high for a biogas engine, so we need a scrubbing. But definitely spent wash is possible. The first installation which we are making in India is more with press mud, but we might as well co-digest with spent wash and also test it with there. But spent wash shouldn't be a problem, because spent wash is a very good let's say waste for biogas generation.
Thank you, Mr. Joseph. The next question is, what is the material of the fabric?
The material of a fabric, it's a special high-tech polymer. I'm not completely aware of this. This is up to our partners, the parent company in Sweden. They might be able to provide these details. But it's a special material which is being used and which is being tested.
Right. Thank you, sir. The next question is, do we have any installations in Indian sugar factories?
That's what I was saying. The first installation will happen in next 1 or 2 months. So we are planning to put up in 2 sugar mills in south of India. So it should be in like maybe two months or 3 months. They should be in ground.
Okay, thank you, sir. We have the next question here, which says, how is the slurry pumped in and out, and what are the pumping system details?
The slurry, when it comes to slurry system, is more based on a gravity-based movement. The mixing is going to be placed at a certain level, and the digester is going to be another level. And when it comes to the slurry, which is being used, it will be connected directly to, let's say, base system. Like many, for example, sugar mills have a ETP plants, be connected to these ETP plants, and it depends upon the quantity and the pumping would the small scale pumps could be used for corresponding, the flow, what will be the flow. So definitely pumps could be installed as well, but it depends upon the size of the plant.
Thank you, sir. The next question here is it a continuous process or a batch process?
Well, it's more like I would say it's more like a batch process in the sense you have to feed in the digester, like feedstock every day. It could be done at one time in a day, or let's say 3 to 4 times in a day. So it's more like a mixture of continuous, because the idea is to not to complicate the product by not adding some sort of automatic feeding system or pumping system, because as you see the digester, then the cost is going to increase, like if you have automatic feeding system or so on. But it's ideally handling it with a pre-treatment tank, and if you could use a JCB, for example, one day you could load into the digester, the pre-treatment tank. It could just 1 ton or 2 tons into it, and then the process would be automatic.
Thank you, Mr. Joseph. The next question is, how long we can operate continuously without shutdown for maintenance?
Well, it depends how one operates. If you operate according to the prescribed way, maybe once in a year or 2 times in a year should be fine. And it's also, as you can see, it's also very easy to clean the product because you see it's the openings are, we have opening for cleaning, flushing out the waste and so on. So, and we have no moving parts inside the digester, so which makes it more easy for maintenance.
Okay. There's also a request asking for the plant which you are going to install in 1 or 2 months. Can you share the details, sir?
At this time, not probably, but depending on individual mills, they could always send us an email, so we could definitely let them know.
Okay. Thank you, sir. The next question is, what is a medium used if it is fully spent wash based?
You mean the medium? It's the same digester. It would be the same digester.
Okay. And is there any subsidy given by the government of India as of now?
Well, there are subsidies. It depends upon the size again. Let's say if you're talking about 1 megawatt size power plants, we have a 1 to 1.5 crore Indian rupee subsidy for every megawatt of installed capacity. For example, I would say, investment is more interesting in sugar mills, because the reason being, in few years, most of my friends from sugar industry might know that the government might go for a zero discharge policy, which means the spent wash is not going to be generated anymore. Like, for example, in states like Tamil Nadu and Karnataka, there is already a very stringent environmental condition, because most of the sugar mills are going for zero discharge, where they incinerate the spent wash instead of biogas generation. So yeah, I think press mud is more interesting. Of course, spent wash could be used as well, but I don't think the governments are going to give any license for new spent wash based digesters. But there is a subsidy of 1 to 1.5 crore per megawatt of installed capacity, so you can convert it into correspondingly into 1 kilowatt size. Yeah.
Sir, thank you. The next question is, what is the cost of 1 megawatt power plant, and for a 1 megawatt power plant, what is the capacity of the digester?
For 1 megawatt power plant, it could be around, let's say, 5,000 cubic meter or something in that level, around 5,000. So it will be multiple modules. It will be separate modules, or like 4 to 5 modules. So it depends upon how we design for the customer.
Right. Okay, sir. The next question is, what are the recurring purchases from the supplier required?
Well, the most important thing would be the maintenance, because as you see, there are not many moving parts here. So the piping and all the let's say the works and connections, those kind of things have to be maintained. And when it comes to because we are more on the digester sides, if the customer is going for an engine, so the engine would need some maintenance as well. So the engine supplier might provide the maintenance contract. From our side, we will kind of may provide a maintenance support for taking care of the digester parts and other accessories.
All right. Thank you, sir. The next question is, can we use the biogas to produce steam in small scale for up to 1 or 2 kg pressure?
Yeah, you could definitely use for steam at that level. Definitely, you could use a biogas burner, or you could have I think most of the sugar mills have an existing boiler as well, so we could use low pressure steam. I would say it's more low pressure steam. Yeah.
Right. Thank you, sir. And for a 100 TPD press mud, what infrastructure is required and how much gas can be expected?
So for 100 tons, if you're talking about 100 tons, that's more in industrial scale. You could get like around 850 kilowatt power for a 100-ton plant. That's close to 1 megawatt capacity plant. And yeah, so that's the size expected level. You could have 1 megawatt power.
Oh, sir. And what is the composition of the gas generated?
When it comes to this particular gas, the press mud based gas, you will have 60 to 65% of methane, 30 to 32% of CO2. H2S levels are very less, like it's less than around 300 ppm, I would say. So that's kind of the proportion. And it's much more cleaner than spent wash based gas, because here we don't have high levels of H2S, because sugar mills have a huge problem with the high H2S levels in the spent wash, which is leading to a shutdown of many engines or boilers, or they have a lot of problems. So this is a very, press mud is a very good feedstock, since we have a very low H2S. So it's a good thing for sugar mill.
Okay, thank you, sir. The next question is it just sufficient if the spent wash is fed in, if there is no medium?
Actually, I think he's asking about the column. You can add to start the. I think he's talking about this biological medium. So see, there are different types of biogas digesters. There is like continuous stir reactors, or you have this biological medium-based reactors. So this operates without any medium. So this is more on a natural process.
Sure, sir. The next question is, how much low pressure steam can be produced by a 100 TPD press mud?
100 TPD press mud, it could be around 5 kg per centimeter square.
All right, thank you, sir. The next question is it necessary to scrub the gas for running gas engines?
If it's below 300 ppm, you don't have to scrub. If it's above 350, 400 range, you have to scrub for gas engines supplied by German suppliers like MWM or MTU Energy, or GE supplies engines, Jenbacher. So above 350 you have to do. But there are many small scale biogas engines made by Indian companies like Ashok Leyland, and also by Mahindra as well. So they have a high tolerance level. Like if it's like an 50 kilowatt or 100 kilowatt, it can go up to 400 ppm. But anything above 500 should be definitely scrubbed when it comes to engines. Yeah.
Right. Thank you, sir. The next question is the fabric the USP, or the medium, if any, is the USP? And explain briefly the technology without revealing the trade secrets.
Well, it's more the medium, the fabric. Sorry, it's not the medium. It's the fabric, which is the USP. As you can see, it's easy to transport, foldable, and it can be installed very quickly and easy maintenance. And also the support we would provide locally as well. So it's a combination of many things. So the fabric makes it much more interesting.
Thank you, sir. And you have also mentioned that we can generate 5 tons per hour steam for a 100 TPD press mud plant. And how much tonnage of steam can be produced? How much steam in tonnage by how much steam in tonnage by 100 TPD press mud?
For a 100 TPD press mud, I would say, see, the thing is like when you're going for 100 TPD plant, I would normally recommend for a power generation route, because when you have 100 TPD plant, there is no point in generating steam because you're almost underutilizing the calorific value of biogas. Because a 100 TPD plant would give you around a revenue of around 4 crores if you go for an power generation route. If you go for steam, you wouldn't even get 1.5 crores. The advantage of the power route is you can always generate power, and the waste heat coming from the biogas engine it can be used as a replacement for steam, let's say for biogas. So the power route is much more cost effective and economically more viable compared to a steam route for a larger scale plant. But if you want to try in a 10 tons or 5 ton scale, then steam could be used.
Okay, thank you, Mr. Joseph. The next question is, what are the chances of any leakage in the fabric?
The chances are less because it's free. I mean, already pre-tested in the industry, like in the factory, and tested and approved, and then it's only installed there. So we are already always there to give maintenance and support. So there shouldn't be any problems of leakages. The material is pretty quite hard, and it's tested to withstand rough conditions.
Correct, sir. And the next question is, what is the life of the fabric?
See, it could be, I mean, it's up to 15 years, but we normally say around 10 years, minimum 10 years. So it could go up to 15 years if properly maintained according to the specifications and proper treatment to the material.
Okay. So which means that we have to change the fabric every 10 years.
Not necessarily. I mean, see, the normal biogas plant lifetime is around let's say a concrete based or a steel based is 20 years. So you get it for here for 15 years. So it's not exactly a replacement. I think the lifetime is around 15 years, I would say. Because a normal digester is 20 years. So we are up there close almost. It could even go to 20 years if you are going to use it properly. But we just give a guarantee, let's say, of 10 to 15 years.
Okay, sir. The next question is, what is the longest operating plant in the world with this installation, and what is the capacity and where is it?
The longest is, as I said in my presentation, it's been like 3-4 months, which or maybe beginning of the year. It was installed in Indonesia. It's a 100 cubic meter palm oil based plant, so it's less than 6 months old. But also I would like to add a point here that one of the unique model is that we have a demonstration time of 5 to 6 months for the client. We set up the biogas plant where they can, the waste they give press mud or cement wash. We would operate them for the first 4 to 5 months. It's like more like a boot model, like the gas generator, the customer buys the gas generator from us on a per cubic meter basis. After 5 to 6 months of satisfied performance, they can always buy the digester in itself. So that's one of the model for customers who want to see the demonstration for the plant. Let's see how it's going to work.
Right, sir. That sounds interesting. The next question is, what will be the tentative cost of 1 megawatt power plant for press mud based biogas?
For 1 megawatt, I mean, if it's a specific sugar mill, we can give it to them, like, I mean, which is a sugar mill, we can contact and get more details, because there are a lot of things like it's power or bio CNG or steam, so we could answer them usually as well. I mean, if you have the name, or you could always contact us through email.
Yes, sir. The next question is, with 6 months operational history, how to take an investment decision? That's more of a doubt from the person.
Okay. Well, as I said, the fabric in itself has been tested for a long time, but the demonstration unit, which is running 100 cubic meter, that's why we give a 6 months satisfaction, because I mean, sugar mills, you install spent wash digesters, most of the digesters kind of fail in 1 or 2 years, for example. But here we are giving a guarantee for 6 months, and based on this you're going to buy it. So it's more like, yeah, you have to like the material, believe in the material and the process.
Right, sir. Any other questions? I would request the participants to kindly type in the chat box below. The next question here is, sir, any maintenance is involved and what is the operational cost required?
See, the maintenance here would be for the cleaning. For example, you have to clean it once in a year or twice in a year. And also you have to keep checking for the piping connections and other, whether if there is any leakage or gas leakage or something. So the operational cost would be like, depends upon the size, of course. So there's a very low maintenance. That's one of the advantages of this particular material. You don't have this media formation or blockage when gas is generated. For example, in a media-based digester, you could have a choking in this in other digesters. Here it's much more natural process, so there is a very low maintenance for this digester.
Okay, sir. And the next question is the fabric same for any type of waste, or is it specifically designed for the waste?
I think it's more unique. It's it's more general for all the type of the waste. This is the material which should be used. But I could maybe consult our partners regarding this, because we have been working for sugar industry and other industries. From their experience, probably there will be change in some proportion, but mostly the base material should be the same.
Right, sir. Thank you. Participants, I would request you to type your questions in the chat box below.
Also, why? Yeah, sure.
Yes, sir, please. Yeah, please, sir.
No, I was saying like my recommendation would be like for the sugar mill specifically, because I know a lot of sugar mills have a huge canteens, or they have a housing units, like people like 300, 400 people living close by the sugar mill, people who are working to initially have a demonstration using this particular press mud, for example, install the digester. You can always scale it up from there. That could be a very good testing to begin, demonstration to begin in using this particular waste. With just an tip, like indicator how it could be started, for example.
All right, sir. If there are no other questions, I would like to thank Mr. Joseph for this valuable session, and I'd like to thank also the audience for the kind participation. The recorded session of this webinar will be sent to all of the participants over email, and there is also the B2B meetings which are being conducted on 23rd and 28th of April, wherein this FOB Biogas and other Swedish technologies are coming to India for a B2B partnership. So we would request all the participants to kindly attend the B2B webinars also to understand further. Thank you very much. Thank you, Mr. Joseph.
Thank you very much.
So we formally end the webinar here. We would be sending you the recorded session, the link of the recorded session. And for any further queries, you can kindly write to Mr. Joseph or Mr. Frederick from FOB Biogas. Thank you.